Hello and welcome to another session of Introduction to Engineering and Architecture. In this video, we will talk about angles of elevation and depression. We will distinguish the difference between angles of elevation and depression and solve problems involving angles of elevation and depression. So what are angles of elevation and depression? Angle of elevation is the angle created when the line of sight is above the horizontal. On the other hand, angle of depression is the angle created when the line of sight is below the horizontal. In this illustration, for example, the angle of elevation from A is 30 degrees, while the angle of depression from A is 15 degrees. Most of the time, in solving problems involving angles of elevation and depression, we will use the tangent function. We remember that the tangent of a particular angle is equal to its opposite over its adjacent. For instance, in this triangle, tangent of beta is equal to its opposite, A, divided by its adjacent, B. On the other hand, tangent of theta is equal to its opposite, B, over its adjacent, A. Let us now solve some problems involving angles of elevation and depression. An observer in a lighthouse is 285 feet above water level. At his eye, the angle of depression of a boat on the water is 15.6 degrees. Find the distance of the boat from a point at water level directly below the observer. It is helpful if we label the parts of our illustration. Let AB be the distance between the observer and the water directly below them. Let BC be the distance between the observer and the boat. Now, we know that when two parallel lines are cut by a transversal line, opposite interior angles are congruent. Therefore, angle ACB must also be 15.6 degrees. Since triangle ABC is a right triangle, we can use the tangent function. Tangent of 15.6 is equal to its opposite AB divided by its adjacent AC. We know that AB is 285 while we are looking for AC. We have tangent of 15.6 equals 285 divided by AC. Isolating AC by multiplication property of equality, we get AC equals 285 divided by tangent of 15.6. Using our calculator, we know that this equals 1020.76 feet. For our second problem, we have a flagstaff 25 feet high standing on top of a house. From a point on the plane on which the house stands, the angles of elevation on the top and the bottom of the flagstaff are observed to be 60 degrees and 45 degrees, respectively. Find the height of the house. We let AB be the height of the house and C be the point on the plane where the house stands. In this problem, we're looking for AB. Based on the illustration, we have two right triangles, one smaller right triangle ABC and the other larger right triangle with angle 60 degrees. For the smaller right triangle, we have tangent of 45 degrees equals its opposite AB over its adjacent AC. We isolate AC and get AC equals AB over tangent of 45. Moreover, for the larger right triangle, we have tangent of 60 equals its opposite AB plus 25, divided by its adjacent AC. We also have isolated AC to get AB plus 25 divided by tangent of 60. This means that AB over tangent of 45 is just equal to AB plus 25 over tangent 60, since both of these expressions are equal to the same side, AC. We equate them and we can now solve for AB. We first multiply both sides by tangent 45 times tangent 60, thereby getting rid of the denominators. This gives us AB tangent 60 equals AB tangent 45 plus 25 tangent 45. We then subtract both sides by AB tangent 45 to get this expression. We factor out AB, then, to isolate, we divide both sides by tangent 60 minus tangent 45, giving us AB equals 25 tangent 45 divided by tangent 60 minus tangent 45. We calculate and get 34.15 feet. Let's talk about this third problem. Two ships are in the same vertical plane with an airplane. The airplane is 2,000 feet high, and the lines of sight from it to the ships make angles with the horizontal 44 degrees and 32 degrees respectively. Find the distance between the two ships if they are on the opposite side of the airplane. Let AB be the distance between one ship and the airplane, while BC be the distance between the plane and the other ship. BD is the distance between the plane and the point at the sea directly below the plane. We are looking for AC. As with the first problem, we're seeing two parallel lines cut by a transversal line. This means that angle BAD is also 44 degrees and angle BCD is also 32 degrees. For triangle ABD, we have tangent of 44 degrees equals 2000 over AD. We isolate AD to get AD equals 2000 divided by tangent of 44 degrees. For triangle BCD, we have tangent of 32 degrees equals 2000 divided by CD. We isolate CD to get CD equals 2000 divided by tangent of 32 degrees. Now AC is just equal to AD plus CD. We know the values of AD and CD. Substituting, we get 2000 divided by tangent 44 plus 2000 divided by tangent 32. Calculating, this gives us 5,271.73 feet. Let us now discuss our final example. 2 points A and B, 80 feet apart, lie on the same side of a tower and in a horizontal line through its foot. If the angle of elevation of the top of the tower at A is 21 degrees and at B is 46 degrees, find the height of the tower. Let CD be the height of the tower. For triangle ACD, we have tangent of 21 degrees equals CD over AT plus BC. Isolating BC, we get CD minus AT tangent 21 divided by tangent 21. For triangle BCD, we have tangent of 46 degrees equals CD divided by BC. We isolate BC as well and get CD over tangent 46. Since both the expressions are equal to the same segment, BC, we can equate them. We have CD over tangent of 46 equals CD minus AT tangent 21 divided by tangent 21. From here, we can solve CD. We first get rid of the denominator by multiplying both sides by tangent 21 times tangent 46. We get CD times tangent 21 equals tangent 46 times the quantity CD minus AT tangent 21. We expand the right side of the equation by distributing CD. We get CD times tangent 21 equals CD tangent 46 minus AT tangent 21 times tangent 46. By subtraction property of equality, we get CD tangent 21 minus CD tangent 46 equals negative AT tangent 21 times tangent 46. We factor out CD on the left side of the equation. Then, to isolate CD, divide both sides by tangent 21 minus tangent 46. Calculating this expression, we get 48.8 feet.